Okay, so what we will do today is, today we will start a new unit, okay? So this is regarding a new data structure. Called stack. And so far you have learned array and the array list to store a number of items. Okay, so that you have already learned. Because for single variable, then you can only store single value. If you have more than one, then you need to use array or array list to store that. Okay, so what we will learn today is another kind of data structure that can be used for store items, multiple items. Okay. But it has its features. So stack, basically you can kind of view it like a container. You can kind of view it like a container. And suppose you have something to store it. Okay, suppose you have some book, is it? So you put a book in, is it? So book 1, you drop it in. And then for book 2, the only place you can drop is on top of book 1, is it? It cannot be at the bottom of book 1 unless you remove book 1, is it? So if you just drop book 2 inside, then the only place you can put is on top of book 1. And then you may want to drop more, is it, like book 3 and book 4. And like book 5. Then maybe at this point, your container is full, okay? You cannot hold any more books, is it? So from what we just saw, the actions that we did is each time when you want to add something, you can only add at the top, is it? So each time it's add at top, add at top, add at top, add at top of existing kind of piles, is it? You can only add to the top of the existing piles. Okay, that's what we can view. And also, you can only access at the top. You cannot add access from bottom, because we can only access it to the top. So after we add, then we can only reach the top item. For the bottom item, we cannot reach unless you remove the top item, is it? So only top item is reachable. Here, is it? Only book 5 is reachable. Okay, and book 5 also, if we just think about closely, then book 5 is, so the top item is reachable only. And the top item also is what? The top item is also the last item be added. Is it? It's also the last item be added at the top. Okay, and the first item, this is the first item. First item we added is at the bottom. At the bottom. And when we do remove, then we remove also from top. Is that whenever we do remove, we also remove from top. Is it not from bottom? Only after you remove the top, then when you reach the bottom item, then you can remove it. Is it? And the first time added at the bottom, that means it is the last one be removed. Is it? It's going to be the last one be removed. Okay, so here it kind of has the last item has kind of enjoyed some privilege. Is it? Even though it's the last one added, but the first one get out. Is it? Okay, so this kind of feature that we just described, it's called last in, first out. Is it last in? So book 5 is the last item to be added, but it's going to be the first item out. Is it? So last in, first LIFO. Okay, we call it, it has a LIFO feature. So this LIFO feature basically is our stack data structure. Okay, so this kind of storage, then we can call it a stack. Okay, if you think about array doesn't have this. Array list also doesn't have this. Is it? For them, it's just, we don't care about the order. Is it? It's just where the item is, its index. Is it? It's index. So it's fast to access specific items through its index for array and array list. Both have this feature. Okay. Okay, so stack, then we can see it's definitely different from the other two data structures. So it has its own feature. And also just remember, you can only access at top. Okay, if you want to access other items, you need to remove them first. Otherwise, they are not accessible. Okay, and it has LIFO feature. So this kind of structure, we call it a stack data structure. So here we understand the concept of a stack data structure. So next, let's see, how are we going to implement it? So implementation of stack. That implementation of stack, anyways, it needs to store more than one item. So you need to use something can store group collection of items. So far we have learned array. Is it? So let's first take a look. How are we going to implement a stack using array? Okay, and here let's take a look with the case of the integer. Okay, the integer. Okay, so this is a stack. Suppose it's we are going to do an integer stack. Okay, integer stack. So we have some numbers we are going to put into the stack. So the first number we are going to add is 100. 100, then you can clearly see then it's at what? Sub-0, that you can add it. If we use an array to store it, that. Okay, and then the second item you're going to add is 200. Then 200 is going to be added at sub 1. Is it? And then 300 you're going to add. Then you can put it at sub 2. Is it? Then 400. So it's sub 3. Okay, then 500. It's sub 4. Is it? Sub 4. Okay, so that's the so assuming the array size here. Okay, assuming the size is 5. Okay, it's 5. So now we have this array store of the items, but when you can access, you can only access 500. You cannot access 400, 300 to 100. Okay, so if we take a close look, then we can also find each time when you add a new item, the array index increased by 1. That is start at 0, then 1, then 2, then 3, then 4. Is it? So each time when you add 1, the array index is increased by 1. Okay. Okay, and then next, let's see, when we do the remove, okay, we remove 500, so it's being removed. But the array is still here. It's just that item is not on the stack. So we need something to log the top items index. Previously, when 500 is there, the top index is 4. Is 4. Is it when 500 is here? And then we remove. Is it? Remove the top index, change it to what? To 3. Is it? So basically, the top index move to 3. And after we remove 400, then the top index change it to 2. Is it? And after we remove 300, then the top index change it to 1. Is it? And after you remove 200, then the top index change it to 0. Is it? And after we remove 0, and based on the pattern, then the top index should be -1. Is it? Because each time when we remove an item, the top index is decreased by 1. Is it? Is decreased by 1. So when it's empty, then the top index changes to -1. Is it change to -1? So and then this also applies. Is it when initially if it's empty, it's -1. Whenever we add 100, it's 0. So it's increment by 1, then it's 0. So that's also applies. Is it? So we can see basically if top index is -1, then that can means this stack is empty. So we can set the indication of a stack is empty as the top index as -1. Okay, and the array capacity is 5. So when the top index is 1 less than the size, then that means the stack is full. In this case, is it? Then you cannot add anymore. Okay, so here just when we implement using array, just some restrictions here. Okay, restriction, and also we also see whenever we do add, the top index is incremented by 1, and the corresponding array item is also going to be assigned with the item. And when we remove, the top index is decremented by 1. But how are we going to remove, clear the array item? Basically, there is no way, etc. So we can revisit this, okay? So let's just think about it. Is it in Java, is it whenever you have an array, suppose in this case, our stack, the array used to hold of the item, we call it M array. Okay, M array. And because it is integer, is it? And because it's an array, you need to do the new int. Suppose the size is 5. Is it? Then in this case, on our heap memory, is it? So there is an array, integer array, is it going to be allocated? Is it? And each is 16 bytes or 4 bytes. 4 bytes of memory, is it? And you have 5, so it's totally 20 bytes of memory allocated on the heap, okay? For the array case, okay? And so we assume the stack holding container is called M array, okay? And the size is 5, okay? It's an array and it's an integer in this case, okay? And if you recall, we also need what? We also need that top index. So we can name it like as M top, is it? And the type is integer. So this is for the index. The top index, okay, the top index. Okay, and then let's see how are we going to implement using an array and the top index for our stack, is it? So we come back. Okay, so initially our stack is empty. When it's empty, the top index is -1, as it is -1, okay? And then we have 100 be added. 100 where we add? We add at M array sub 0 is 100, is it? And the top index should be updated to 0, is it? Increment by 1. Okay, so this is M array sub 0, is it? It's going to store this item. Okay, and then you have 200 going to be added. 200, then it's incremented by 1, is it? So M top is 1. And then your array, where it's going to be at? It's going to be at the second slot of the array, is it? And now you have 300. So it's an array sub 2. Is it? And then that means your top index increment by 1. Is it? And then you have 400. Okay, so here then an array sub 2 is going to hold 300. Is it? Then you have 400. So the top index is going to be 3. So it's plus 1. Is it? And your an array sub 3. Is it? It's going to be added. So an array sub 3 is going to be 400. Okay, and then that 500 is going to be added. So the top index is going to be increment to 4 by 1. And then the respective item is going to be used to store 500. So then an array sub 4 is 500. Is it? Because your array size is 5, so now your array is 4. And if you have another item 600 you want to add, there is no way to add, is it? Because then we say stack is 4. So it cannot be added. Okay, so this is when we use an array and we have the top index. How are we going to keep track of the stack? Is it? So the stack basically is being tracked by what? So the top index. So top index can be used to keep track of the stack. Is it? Okay, so that's whenever we want to add new items to the stack. How we add a new item to the stack, is it? And in data structure, add a new item to the stack, there is a specific name for it. It's called push operation. So add an item at the top, we call it push operation. Okay, push operation. Okay, then let's see. How are we going to remove? If we want to remove this 500, is it? And can you clear the array item? Basically, there is no way you can clear the array item here, is it? So, but over here we said the top index is used to track of the stack, is it? So we know, okay, if you want to remove 500, basically the top index is decremented by 1 to 3, is it? So the top index is changed, but 500 can still be associated with that array, is it? So 500 is not on the stack, but it's still in that array. Okay, your stack is just referred to that array and the top index. So similar, when you want to remove 400, it's still associated with that array, but it's not in the stack. Okay, but your top index got decremented by 1 to 2, is it? And if you keep doing, is it 300 if you remove? The array is still, item is still there, you cannot clear, but your top index decremented by 1. So the top index changed to 1, updated to 1. Okay. And if you remove 200, then it's decrement by 1, is it? It's changed to 0, the top index. Okay. But all of the items, they are still there, is it? And if you want to remove 100, okay, it's not on the stack, but the item is still with the stack, but your top index got decremented by 1 to what? To -1. Okay, to -1. So now your stack is what? Your stack is empty, as it is empty. And the top index is -1. But your array, be careful, okay? Your array is still holding those items. We didn't change the array. We just changed the top index. But your stack itself is also empty. Okay, and for remove top item from stack. In stack, there is a specific name called pop. So whenever you see pop, that means you remove the top item from the stack. Okay, from the stack. Okay, so now we kind of have general idea about a stack and the operation related with the push and pop. Okay, so what next? Let's see about stack data structure. Okay, and we already learned whenever so in Java, is it if you wanted to describe certain category of object, you can create a class, is it? So same thing for the stack new data structure, we can define a stack class. Stack class, okay. And assuming in this case, we are going to discuss the stack regarding to store integer, okay. And whenever we create a class, previously we also learned that you create the UML diagram. And within the UML diagram, then we need to specify its instance variable. For stack, we just say that we need that top index and the type is integer. And we also need an array. And the type is also an integer. Okay, the capacity is 5. Okay, so those are 2 instance variables. And then whenever you design a class, generally speaking, we need what? We need a constructor. And normally you can have a default one and some one with parameters, is it? So the constructors here, what we will say is like the default. So the default one will just create an empty stack. And some other type, okay. So maybe you wanted to fill the stack with some item from some array, okay. So anyway, so that's regarding constructor. And regarding a class, we said we normally need some set method and some get method. It's an accessor and the mutator. So over here regarding mutator is what? We need some, we add item. So that's what we care about the most. We add an item at the top. So it needs some item as a parameter. And the return type can just be void. Is it? So what it does is add a new item at top. Okay. And then what? Then pop. Is it? Pop is just what? Remove an item from the top. And generally speaking, because you just remove from the stack, so it's not a through parameter. etc. So the parameter can be left as empty, and return type is void. So over here is what? Remove top item. And also, normally what we interested is what? If we also wanted to do some accessor, to retrieve some item. And over here, you can only retrieve the top item. So we can provide an operation called top. The top is going to retrieve item from the stack. And stack type is integer. So the return type should be integer. So this is to retrieve top item. But be careful, okay, not to remove it. Okay, not to remove it. And probably you will have some other operation you want to add. As a generally speaking, we also, for Java, we also have two string. Is it? And that is return type should be string. Is it? It's you just want to display the stack contents. There may be some other operations we are interested. Okay, so anyway, so this is if we want to describe a stack data structure using an array, that's normally what we need. Okay, so you can also say it's not too complicated, is that not a big deal. Okay, so that's regarding the concept of stack and its implementation using an array. Okay, so next let's take a look how our coding looks like. Okay, where is my hold on. Oh, yeah. Need to find my Java code. Okay, then next let's see. The first example we are going to see is about the implementation of our integer stack. So this is the first example in our course website's Java stack example 1. We have two files, stack integer.java and a driver. Okay. So for stack integer.java, it's regarding the integer stack class. Okay. And here we also let it to implement a clonable interface. And remember, okay, clonable interface is very special. It's called a marker interface. Marker interface, if you recall, that clone method, this clone method is from object class. Okay, it's not an abstract method from clonable. This clonable is just, once you implement, then that means this class must implement that clone method and should also provide a deeper copy of the class itself. Okay, the object itself. Okay, so for this class, we already see those two instance variables. Okay, we use an array, we have top index to store the item, to keep track of the top item. And here we also have a constant for the array's capacity. Here we said it's 8. Okay. And then next, let's see. So the first one is a default constructor, the constructor without arguments. Okay, so what it does, it's pretty simple. Is it to just assign the top index to -1 and create an array. Okay, integer array with the specified capacity. So this step happens, so occurs on heap. Okay, on heap, because the stack object, the object is also created on heap, but it's referenced through a variable in stack memory. Okay, later on we will see that. And we also have another constructor. Constructor 2, and this one it take an array as argument. So the array is created, and the top index, we also make it to, because then in this case depends on this array, how many items in this array, so we initiate to the array's length. Okay, and then over here, because this array's size may be larger than the capacity of our stacks array, so that's why over here we make it into a try-catch block. Okay, because we want to do the assignment, assign item by item from the array to our stack, But in case if this P array is larger, then we are going to say, okay, it's array index out of bound exception. Okay, then we just update our top index to the capacity -1, because that's the maximum size for our stack. Okay. Okay, so this is regarding the second constructor. And for array, for stack, this is also one of the operations that we should also take care of. We want to know if the stack is empty. That's pretty simple, just a Boolean method. You just check, how do we check the empty condition? If the top index is -1. If it is -1, that means the stack is empty. Okay, and then let's see the push. And also be careful, whenever you want to add a new item, you need to be aware of the array. You shouldn't let array go out of its bound, So if it's already out of bound, you need to have this exception, the array index out of bound. Okay. Otherwise, if it's everything is normal, then you just increment the top index. So be careful, okay? Here you need to update top index first, then you assign, item to the array. Okay, you cannot do the other way, because the top index represent the current top items index. Okay, so that's, you need to be careful. And if it's out of bound, then you also need to decrement the top index, because over here you already increment. Okay, so this is the push operation. And then let's see the pop. And the pop, if you recall, basically for what we just discussed, is you just update the top index. So basically we just decrement the top index by 1. Okay, we just have, for the array, we don't need to do anything. Okay, there is no way for us to clear the array here. Okay, so we just update the top index. But if the stack is already empty, then we should throw an exception. Okay, and the exception is going to be catched by the catch block. Okay, so this is also straightforward. And what is the next one? discusses about the top. So top is a get method. But whenever you do the top, the stack shouldn't be empty. If it's empty, that's why here throws exception. Is it? Otherwise, you just get to the top item. So if the top index is greater than -1, then you can return the top item. Okay. Otherwise, you need to throw an exception. Okay, so that's regarding the top operation. What next one is that toString. Okay, for the toString, what we are going to output in this implementation is we are going to output from top to bottom. Okay, so from top to bottom, we are going to output one by one, okay, and separated with a new line, okay. So we are going to concatenate the string, and then we return the string. But of course, if your stack is empty, then you have nothing to output. So that's why you just output the stack is empty. So that's regarding toString, not too difficult. And for the clone method, and what over here we want to do is we want to do deeper copy. Is it? We want to do deeper copy. And to do deeper copy, that's why over here we have a stack integer object created. So you create a new stack object. Is it? And then you copy index, top index, and what? And array items. And array items. Is it? One by one. Is it? One by one. So over here you call array.clone. Then this will create a deep copy of array. Okay, then we return this new item. Okay, new stack. Okay, so what basically over here it does on heap. So this is a heap memory, is it? So initially you have, so this is that M array. Basically that's this dot M array, is it? And it has some items. And then over here you have that object, this is going to point. So basically it's some stack. So in main, not main. So yes, this is, no. This is our driver, okay, so runtime stack. So we have that main method. Is it? You mean if you create an object like a stack integer, is it? You do some variable, then you do some new stack int. Is it? Then that's going to point to some object created, is it? And that's going to refer to this array because within this new, it's also create an array of size 8, is it? So you have 8 slots, is it? Let's refer to this. So what this clone does is, okay, to create another one, is it? So this new, let's create another one. That one going to create. So this array.clone is going to be this one, .clone. Then it's going to unheap. Okay, so this is M array. This M array is whose? Is this clones. Okay, this clone. And then this guy is going to refer to this one. So then you can clearly see that it's completely two different copy. Each one has their own. And this guy get to return. So this basically is that ST. Okay, that ST. So that's how this clone, we say it's a deep copy one. Okay, then later on, if you change value here, it won't impact the original. Or if you change it won't impact the clone. Okay, have nothing to do with this. They just initially they share the same values. Okay. So that's regarding this clone method that we implement. And then let's take a look how we use a stack. Over here, so to use a stack, then you just like what we did with all of our previous class, is that you just knew some class name. This is stack integer. And here we are going to add this array list of item to our stack. Then you just call push. Is that here you use a loop to add item by item to the stack. And here we output our stack. Basically over here it's equivalent to you invoke that to string. Is that you invoke it? And if you want to add another item, 1, 2, 3, 4, 5, 6, 7, it's already 8. You will see some exception going to happen. Okay, if you see this stack and the previous stack, it's the same. And then over here, we call the clone. Okay, we call the clone, so this is the copy, is it? And we remove the top item. After we remove the top item, we can check the original, that if it's impact, we will say it's not impact, it's only happened for the copy one. So even though this item, is it, it's removed, but for this one, the 99 is still there, okay. Okay, and that's regarding the clone we already see, is it? And what this part try to show is when the pop, is it? Because over here we have that top, okay, and the top may throw exception, is it? So that's why over here we put in this try-catch block. Okay, and normally whenever we use stack, we also use this quite often. We pair the top and the pop together. Okay, because you first retrieve top item, is it? And then remove top item. Okay, then we can remove. Okay, so this is how this part works. Okay, then we can check if the stack is empty. If the stack is already empty, if you try to do the top, it will throw the exception. The exception is going to be caught here. Okay, and we can also see basically the stack is also the reverse of the original array. Okay, later on we will discuss this. And we can run this example and take a look, the output. Okay, and if you recall, 29 is first added, 99 is the last added. And you can see the output. And if you recall that toString method is top-down output. So that's 99 is the output first. 29 is the last output. So this reflects LIFO, last in, first out. Then when we want to add more, we cannot, is it? Because stack is full. It says after stack is full, it's output. Basically, we cannot add that new number, is it? And then after we remove the top here, we remove the top from the clone, is it? And the original, you can see 99, it's still there, is it? It's not impacted. And the stack, then we do the loop to remove, is it? To do the pop. So it's empty after we remove off the item. And then when you want to get to the top item, it's through this exception. Is it? And here it just shows reverse of the array is 99. Okay, 229. Okay, that's all regarding the introduction about